Now let's see how to do this type of question, right? Propose a method to identify each chemical species. Here I am going to do the C part, right? Species in the following test sets of chemical using the given method of reagents, right? Now we are going to find out, identify ammonium carbonate, ammonium sulfate and barium hydroxide by mixing pairwise and also by using nitric. The specialty of this kind of question is you can't use other reagents otherwise given except these, right? These are the only reagent that you can use. They are talking about mixing pairwise. What is the meaning of mixing pairwise? Right. Sometimes you can think we can easily find out what happens if these two reagents mix with each other. As example, barium hydroxide and ammonium sulfate, barium hydroxide and ammonium carbonate. Right? You can simply think about that and you can say when you put barium hydroxide into the ammonium sulfate, ammonia evolved. That is same reaction for the ammonium carbonate. Again ammonia evolved. Then the sulfate produce barium sulfate with barium hydroxide. Likewise, ammonium carbonate produce barium carbonate with barium hydroxide. Both are white precipitate. Right? But when you put nitric acid, barium sulfate continuously remaining in the solution as a precipitate because it doesn't dissolve in nitric acid. But the barium carbonate does. Okay, based on that, you can write down the answer. Very simple. Right? This is the simplest answer that can be given. What is the answer? But the problem is, we don't know what is the barium hydroxide. If you know the barium hydroxide, it's okay. You can put into the ammonium sulfate, then white precipitate can be observed. It doesn't dissolve in nitric acid. When you put barium hydroxide into the ammonium carbonate, right? So barium carbonate get precipitated, then it get dissolved in nitric acid. It's okay. You can write like that. But the problem is, we don't know what is the barium hydroxide. Right? Okay. Now, I am going to explain much better logical method to write the answers for this kind of pairwise mixing. Pairwise mixing. So this is the most logical answer that can be given. Right? Now, listen carefully. You can write table like this. Ammonium carbonate, ammonium sulfate and barium hydroxide. Ammonium carbonate, ammonium sulfate, barium hydroxide. These are all possible type of pairwise mixing. Right? These are the all possible type of pairwise mixing. Right? Now you are going to write the observations regarding to these pairwise mixing. You need to understand what is the importance of making this kind of table. The importance is you can't miss anything. You can't miss anything by using this kind of table. However, if you going to think about this type of question, without using this table, something can be missed. Right? So it is better to write this kind of table. Right? Always, if they talk about pairwise mixing, write this kind of table. Right? This table show us about all the possible outcomes. Right? Now, when ammonium carbonate react, no reaction. Ammonium carbonate, ammonium sulfate. Right? What kind of things that can happen? This is, can ammonium sulfate react with ammonium carbonate? Sometimes you may think they can't react with each other. Right? However, you need to understand ammonium sulfate has acidic character because it is a salt of what? Salt of weak base and strong acid. Ammonium carbonate is a salt of weak base and weak acid. What are the strong acids? You know that? Sulfuric, nitric, perchloric, HCl, HBr and HI. These are the strong acids. Salts including strong acids and weak bases shows acidic character. Salts including weak acids and strong bases shows basic character. Salts including salts of both strong acids and strong bases do not show either acidic or basic characters. They are neutral solution. So the ammonium sulfate is the acidic solution. What about ammonium carbonate? Ammonium carbonate has both weak acid and both weak base. So their properties are not clear. But one thing is clear, ammonium sulfate is acidic than ammonium carbonate. So what can happen when the acid is added to the carbonate? Carbon dioxide can be evolved. Right? Therefore, you can write here gas evolved. That the gas is what? Carbon dioxide. Ammonium carbonate, barium hydroxide. Barium carbonate can form, and upon the addition of barium hydroxide into the ammonium carbonate, ammonia release. The gas is ammonia release, and also barium react with carbonate to make barium carbonate precipitate. So you have two observations, right? Gas evolution and precipitate. The ammonium sulfate, ammonium carbonate, again same observation. Ammonium sulfate, no reaction. Ammonium sulfate, barium hydroxide, barium sulfate precipitate and ammonia evolved. This time you have barium sulfate. Barium hydroxide, ammonium carbonate, again this one, same observation. Barium hydroxide, ammonium sulfate, this one, and barium hydroxide, no reaction. Right. Now what we did? We got all the possible outcomes. Right. Then, secondly, you need to make practical table. So this is theoretical table. Then you need to make practical table. What is the practical table? Yes. You can draw the practical table like this. What you need to do? Label the samples as ABC, because practically you don't know their names. So label them as ABC. Right? So these are the ABC in beakers. So the beakers labeled as beaker A, beaker B and beaker C. And take out small fractions of A, B and C into the test tube like this. So these are the beakers, these are in the test tube. Now you can mix them and write the practical observations. You may have precipitate, gas evolution, gas evolution only, right? You can write like that. Okay, now again, think what we did. We make the theoretical table with all possible outcomes, and then we make the practical table by labeling the beakers as ABC. Now, this is the important part in the question. Now you can compare this theoretical table and practical table. You can compare this theoretical table and practical table. Right. Now think, upon the addition of A, you can see, upon the addition of A, you can see precipitate and gas evolution, precipitate and gas evolution. Right? So, here, it was happened for the addition of barium hydroxide, right? According to the practical table, upon the addition of A, you can see precipitation and gas evolution. Precipitation and gas evolution. In the theoretical table, it was happened for the barium hydroxide. Right? So, what is A? A is barium hydroxide. So, this is the most logical answer that can be given. Again and again, think what we did. Make the theoretical table with all possible outcomes, and then do the practical by labeling the ABC, beakers as ABC, by mixing each other. Then compare the observations. Likewise, you can see, you can find out reagents. Now, how to write the answer? Right. Now, how to write the answer? You can write, mix all the species pairwise. Right. Only barium hydroxide produce 2 precipitates and gas evolution. So that can be separated as barium hydroxide. Right? The remaining 2 is ammonium carbonate and ammonium sulfate. Right? Both have same observation. Gas evolution and precipitate and gas evolution. Gas evolution, precipitate and gas evolution. Same. Right. Now you separate the barium hydroxide. Now, it is a time to use nitric acid. It is a time to use what? Nitric acid. Then you can put nitric acid into the 2 precipitates. This and this. This and this. 2 precipitate. One of the precipitate is barium carbonate and other precipitate is barium sulfate. So upon the addition of nitric into this precipitate, it dissolves. Right? So it's corresponding to the ammonium carbonate. Other one is ammonium sulfate. Okay? Again, I will read the answer. Mix pairwise. Mix all the solution pairwise. Upon the addition of barium hydroxide into other two, it make two gas evolutions and precipitates. So it can be separated. Right? Then put nitric acid into the precipitates that forms upon the addition of other two solutions. One precipitate get dissolves and one precipitate remaining. The precipitate dissolves is regarding to the addition of ammonium carbonate to the barium hydroxide. Another one is ammonium sulfate. So this is the answer that you can write here. This is a theoretical explanation, right? So no need to write all of these explanations, right? No need to write this, but just something to think. But what I explained, something to think. So, okay. So what is the answer? Mix the all solution pairwise. Upon the addition of barium hydroxide, it produces gas release and two precipitates. So the barium hydroxide can be separated, right? For the other solutions, it is possible to observe precipitate and gas release. Precipitate and gas release. So check the precipitates with nitric acid. Then you can find out the identity of regarding relevant solution. Right? Understand? Okay. So please ask me if you have any doubts about this. Right. This is the answer for the question, right? Now this is the thinking pattern, the logical pattern. Make the theoretical table, make the practical table, and compare the results. Right? Okay. Sometimes this question can given regarding to the 4 reagents, for it's become bit complex. Later we can do that kind of questions, right? Okay. KOH, sodium chloride, acidic. Using red litmus. Using red litmus. It is very easy. One. First, dip the red litmus paper in KOH. In each of those solutions. First, dip the red litmus paper in each of these solutions. Potassium hydroxide is basic. Sodium chloride is neutral. Why? It is a salt of strong acid, strong base. Acidic acid is acidic. So when you dip red litmus in potassium hydroxide, it turns blue. In sodium chloride, it remains unchanged. In acidic acid, red litmus remains unchanged. Right. But what you can do? Remember, you got blue litmus paper, right? Because when you put red litmus in the KOH, it turns blue. So that blue litmus paper again dipped in acidic acid. So it becomes red. So what is the observation? What is the answer you need to write? Dip red litmus paper in each of the solution. Potassium hydroxide, make it blue. Sodium chloride, make it no change. And dip the blue litmus paper in the other remaining. Right, wait a minute, I'll explain like this. Use 3 piece of red litmus papers. That is better way. Use 3 pieces of red litmus paper. So 1 piece of red litmus paper added to all these solutions. So you can see 1 red litmus paper turns to blue and other other two remaining colorless, unchanged, right? So the solution that turns the piece of red litmus paper to blue is potassium hydroxide. Label it and keep it beside. And take the blue litmus paper, right? Immerse and dip it in other two solutions. Sodium chloride. In the sodium chloride, no change. It get turned red when it put into the acidic solution. So what is the answer? Take 3 pieces of red litmus papers and put it into each of solution, and one make red litmus blue, right? Take that blue litmus paper and again add it into the other remaining two solution. Acidic acid, change it, turn it red. So it is acidic acid. The remaining one is sodium chloride. 3. Heat into high temperature. Ammonium dichromate. When ammonium dichromate is heated up to high temperature, what are the products? When ammonium dichromate heated, you have N2 Cr2O3 plus water. Cr2O3 is green in color, bluish green, actually, bluish green. Bluish green in color, right? Zinc carbonate produce zinc oxide plus carbon dioxide. Magnesium carbonate produce magnesium oxide and carbon dioxide. Right. So your answer should be like this. Right? When these 3 compounds are heated up to high temperatures, only ammonium dichromate produce green solid and other two produce white solids. However, white solid of zinc oxide is pale yellow. I told you it. Then the other one is magnesium carbonate. So what you did, right? When these 3 compounds are heated up to high temperatures, ammonium dichromate produce green residue and other two make and zinc carbonate make pale yellow residue, and the other make magnesium carbonate produce white residue. Right? Okay, that is the answer for the question 7b part. Right. I will explain C part in the next video. Right? Okay. Thank you very much.